So just to get a good gauge of the audience, how many people here use Django or like are interested in it in general? Awesome. All right. I'll stick with this talk then. So hi, everybody. My name is Kenneth Reitz, and you can follow me online at Kenneth Reitz on Twitter. And I work for a company called Heroku, which is a really great application platform for deploying web apps. We're also looking to hire some interesting folks that want to solve interesting problems. So if that interests you, you can come talk to me later, and I'll show you the different openings we have and stuff. And or obviously, if you have questions about Heroku, you can come and talk to me as well. But if you know who I am, it's probably because of the open source that I write. I really like open source a lot, and I kind of try to model my life and kind of everything in my life. I try to make it be like inspired by open source in some way. So some of the projects that I've done that are more popular are the Python Guide, which is essentially called the Hitchhiker's Guide to Python, and it serves to be a documented guide of all the best practices in the Python community. So I think in Python we have a big problem of essentially having a lot of social best practices that all of us know because we use Python for a while, but if you're a newcomer or you're not familiar with a certain area, like these things aren't written down anywhere. So this kind of, the goal of the project is to be a very opinionated guide that kind of steps through all these things. And it also, like if you're, say, a seasoned veteran in Python, you've been like doing scientific computing for 10 years and you want to switch to web development, it'll give you nice recommendations on that and stuff like that. And of course, the ever important recommendation to never panic and always carry a towel. I also wrote requests, which is HTTP for humans. Essentially, it's like really, really hard to make HTTP requests in Python. It can be a little frustrating and cumbersome and actually like make me want to kill myself. So I tried to fix that, and this is the result of that. And essentially, it makes it really easy to make HTTP requests and tries to kind of do all the hard work for you. So you can do like Unicode properly and SSL verification and cookies and all that stuff. So if you are interested in that, you can also come talk to me. I'm always looking for help and contributors and stuff like that. Another project service that I wrote is called HTTP bin, which is essentially a mirror for HTTP requests. So as I was writing requests, I realized that I wanted to write a suite of unit tests. And to do that, like it's really hard to actually know what's being sent across the wire. So curl and like urlib2 and all these different HTTP clients will all send different headers. So like you have like the accept header and the connection header and the content length. All of these things are like different clients will behave differently. So this gives you insight into what your client is actually sending, so you can A, develop on it, or B, just debug things. And it gives you the ability to like challenge basic authentication and like it'll give you certain test scenarios for like status codes and things like that. So some pretty cool stuff. I also wrote a bunch of other stuff that you might be familiar with. There's Legit, which is essentially the workflow that was provided by GitHub for Mac into the command line. So in GitHub for Mac, if you were like switching branches in Git a lot, essentially if you have any unstaged changes, it'll automatically stash and unstash them for you. So you don't have to keep hiding away things or committing things that aren't ready yet. So I brought that to the command line so you can do it, and it's pretty cool. And a bunch of other stuff. There's OSX GCC Installer, which allows you to install Xcode or GCC on your Mac without Xcode, and that its purpose is to anger Apple's lawyers, which it's quite successful at. But anyway, so as I've been writing all this open source, I kind of have this methodology that I've kind of adopted over the years, which is open sourcing all of the things. And essentially, I've really found that it's really beneficial to treat projects as if they're going to be open source, even if they're never going to be. Like if they're internal to your company and no one's ever going to see them outside of the company, if you pretend that the project is going to be open source, there's all these really great practices that start to come to light. So if you're going to build an open source project, usually like the thing that it's solving is very concise and it's decoupled from the rest of any other application it would be a part of. So if you build your project as if it's going to be open source, all these things start to naturally come to light. So concerns start to separate themselves. Things like, let's say you're going to have an open source project that you were going to deploy internally. You wouldn't be keeping your database credentials in your repository, and you shouldn't be doing that anyway. So it kind of keeps you from doing these things that are ideally avoidable. An open source project is completely useless if there's not really great documentation or great tests. And the same goes for your internal projects. And I know we've all been here where you have all those projects that have no internal documentation. And so if you just approach these things as if they're open source, just like get yourself in that mindset, all these things just kind of naturally go away. And there's a lot of great benefits that arise. And a nice little side benefit is that if you do ever want to release it as open source, you can. You don't have to go through and do all these sanity checks to make sure you're not giving away any secrets, stuff like that. But anyway, so Python is a really great language, and all these things that we build, so everyone in here is familiar with Django, and essentially what Django is an abstraction layer for HTTP and for building web applications. So let's go ahead and build something. We are going to build a new Instagram competitor or something like that. We'll call it Hipstagram. And we're going to use Django because Django's awesome, and that's what everyone uses to build things, because we're Python developers. So why do we choose Django? There's a lot of different things that are really great about it, and that it kind of, there's a lot of good reasons to choose it, essentially. It'll make really modular decisions for you. So if you have a lot of sub-applications that you want your application to comprise of, it can make a lot of modular decisions for you. So the way the imports work and the way that you extend third-party modules and things like that, they're all kind of built into Django. You don't have to design that yourself. It makes security decisions for you. So it has really sane defaults. So I have a lot of Rails, for example, will kind of take the opposite approach in some cases. Well, they will essentially not give you the most secure option by default. So GitHub was exploited recently because Rails doesn't. It essentially allows you to update any record with a put or something like that. I'm not sure the exact details anymore. But that's something Django would never do. Essentially, they try to go that extra mile to prevent users from shooting themselves in the foot. And as a user, that's really beneficial because you don't have to, you have a peace of mind about yourself when you're building applications. So it's kind of this natural thing that you get that benefits you immediately. There's really great documentation for Django, and the community has a tremendous documentation philosophy when they come to all of their projects. So you have things like the Django book, and essentially when you go to the Django book, you have all these different paragraphs in the book, and you can comment on every single paragraph. And that actually is what inspired GitHub to do line commits in pull requests and stuff like that. So Django kind of spurred this entire movement of commenting and great documentation for projects, and it really set the standard, I think, for all open source projects today. And that really goes a long way with Django. It's definitely one of its greatest assets. There's a very large number of installable third-party Django apps that you can install and use in your application. So if you want to add something like Sentry or some kind of a mailing list subscription thing, or all these little things that you don't want to build yourself, someone has probably gone through and made those already. You just add them to your application, and all these things just magically start work for you. And of course, with all these things, all these decisions that Django has made as a community, they kind of naturally give you this tremendous resource and community that just kind of grows out of that. And there's a lot of great benefits. You never feel alone. It also handles a lot of things for you. So like I said, it gives you security decisions out of the box. It also gives you an admin and a management interface for your database models. There's really great tools for doing automatic database schema migrations. User profiles, authentication, all these things are just handled out of the box, and these are problems that you're not going to have to solve yourself. User sessions and cookies, internationalization, these are things that there's patterns that are built in for. You can go look it up. There's great documentation on how to do this, and it's something you're never going to have to worry about. So you've chosen Django. This is what you're going to build your application in. Anything is possible for Hipstagram. So your typical Django application is comprised of three main parts of its, let's say, its code base. You have your tools and utilities, your web process, and your worker process. So tools and utilities usually is your manage.py file, all these things that let you add and remove users and do admin tasks. And your supporting services, which could be something like, let's say, Sentry, that's catching your exceptions, or some kind of other service that you have that's doing things outside of the main process. Then you have the worker process, which you can send deferred things to that aren't supposed to happen within the main request dispatch. Let's say you want to send all your users an email at midnight every day. This is something that would happen within your worker process. Usually you use something like Celery for this. And then you have your web process, which kind of has all these things that it solves at the same time. It gives you a really great user interface for your app, so your HTTP interface for your users, for HTML. You have your API service if you have an API for your site. You have your data persistence layers, actually communicating with your database and setting up the schemas and doing all the model stuff. You have a CRUD admin and authentication. So having all these things in a single code base can be really beneficial to you as a company or as an application developer, because you get out of the box all these great benefits from the Django stack. You can figure out the architecture as you go. So if you're not exactly sure what your code is going to look like in 6 months, you can just figure it out as you go, and it makes it really easy to make these wide sweeping changes really quickly. If you have shared modules within your code base, you could have a single utility module that all the other different sub apps communicate with or import, and they can keep your code nice and dry, so you don't have to repeat yourself at all. And you only need to deploy your code once. So you just take your whole app, you push it up to the server or your multiple servers, and it's just there and everything works. You don't have to worry about any moving parts. And these are all really great reasons to use a single code base like this. So if we look at this diagram again of the average Django application, as you start to grow your product or your tools that you're building, I kind of notice this pattern that kind of happens a lot when I'm working with Django applications by a lot of different teams that I've worked with. And essentially, things start to get really tightly coupled really quickly. Oops. So you have your CRUD is interacting with your data persistence layer, which is interacting with your API service, which is replicating features from the user interface. And your models don't necessarily have all of the business logic in them. And you have all this replication and things that are directly coupled with one another at the API level and at the Python level. And things can get really, really messy really, really quickly. So you have defer tasks, which are managing, interacting with your management tools. And it just gets really crazy really quickly. And this can be an absolute nightmare to work with if you're not really careful. So I really like to say that I think that single code bases for these large applications is an evil thing that you should try to avoid at all costs. Really makes components become really tightly coupled to one another. So if you try to make one change over here, it breaks a bunch of stuff over here, and there's all these unintended side effects that happen. You have broad tribal knowledge, which is required to know the code base if it's not really well documented. So someone will go and try to refactor a small part, and everything breaks. Iterative change of very small components can be really difficult, and technical debt has a tendency to spread throughout the whole code base when it's so tightly coupled. And it forces you to deploy everything at once at the same time. So that is a benefit in some places, but in others it makes it quite annoying if you want to, say, have different services be scaled at different, have different resources dedicated to them. So anything is possible with your application, but it'll often be a monolithic app. So I do a lot of other things besides software development. I like photography, and I mess around with synthesizers and stuff like that. And I've found over the years that constraints really foster creativity in the work that I do. So with photography, for example, I use prime lenses instead of zoom lenses. So I can't change the zoom on the camera itself. I have to move with my feet. And that actually forces me to focus on the problem at hand, which is taking photos and actually composing the image properly instead of just tweaking all these parameters all the time. If you have a simple synthesizer that has a few options, and you can actually focus on making music instead of messing around with the sound, which is usually the goal, depending on what you're doing, obviously. But having smaller things is usually better for a lot of tasks. For example, I find it really useful to use text editors instead of IDEs. If you use an IDE, you have all these options, and you can tweak them forever. And there's always these things that you have to overcome if you're trying to actually get code done. It's really easy to get distracted. OSX, for example, I like to use it a lot, and I used to use desktop Linux for years, and I'd find myself constantly tweaking every little setting here and there because I could, and not actually getting work done. So OSX isn't necessarily very customizable, and I find that a really nice constraint that it gives me that allows me to get a lot of work done. And the same is true with monolithic apps and services. So essentially, when you have services, you have a separation of concerns, just like we did in open source. So instead of having this really large application, we can look at our different users of the application, of our services, and we can represent them in two different types. So in that Django application, we had two types of users that are interacting with it. We have end users and we have developers. And if you like treat them as two different consumers of the application, you can think of these as two different code bases. And once you start thinking of things that way, you can start to like compose things together, and you can do some really cool stuff. So this is a very, very simple example of service-oriented architecture. And essentially what you do is you can have an end user's, so usually what you have in a Django application is like your end user's thing, which is like your HTTP version of your website that they interact with, and that just does all this other stuff in the backend. And to the end users, it'll appear the same way, but instead of having that part of the code base power everything, you can have, let's say, an API that your developers interact with and actually build the front end with, and that is actually what's communicating with the database. And then the front end never touches the database at all. It just talks to the API, and then you don't have to build two things twice. You just kind of have all your business logic at the API side instead of like having it replicated everywhere. And it's a really nice way to look at things. So you can have API, we have a front end that consumes the API, and then you don't have to worry about all these little small moving pieces anymore. So just as we were building for open source before, all those things that came to light naturally from that, we can build for services, and all these things start to really come together. So you have components that become really concise and decoupled from one another. If you have a service, it only has to be focused on the one thing that it's doing. It doesn't necessarily have to be concerned with all the other parts of the application. Concerns really start to separate themselves, and best practices emerge. For example, if one part of your code base should not necessarily be written in Python, you could write it in Go or Rust or something like that. And if you like have this pattern already established that different parts are different pieces of code, then that's like a really natural thing to do. Before, like that would have been that's a different mindset to be able to do something like that. Documentation and contracts become crucial. So like if you're building a web application, let's say like an iPhone app, it's like consuming like the Twitter API and the Facebook API, like you wouldn't be able to build those things if those APIs didn't have really great documentation. And the same goes for your services for your application. So if you have, let's say, a code base, or let's say an app that is comprised of 4 different APIs, like you have to have great documentation and great contracts for that to actually function at all, or else it's not going to work. So it forces you to kind of do things properly and have documentation. And services can be scaled separately at any time. So let's say that a little piece that you wrote in Go or whatever that needs to be there can have different like hardware dedicated to it. You don't have to all deploy the whole thing at once. And it allows you to ship your own champagne or eat your own dog food, which is delicious. So when you start to think about things in this way, things start to become really composable if you build them in the right way. And it's pretty nice. So this before, like we had our developers and our end users. We can also have, let's say, we can start to chain these things together. So before we had developers, we had end users, and those are 2 different APIs that we built. Essentially, both of those things could be consuming like an internal API that both of these APIs have access to that's privileged. So if you look at larger companies like Netflix, this is how they operate. Or they have like this really powerful, robust, unrestricted internal API that all these little services that they build can all interact with. And then they just like take a small subset of that and expose that to the users that they can interact with. And that's like the public version of the API. And then on top of that, they can like build the actual front end of the site that people interact with. And like all these things are powered by this lower level API, but no one ever knows about it. And then you can like build pretty nice infrastructures with like, message queues and workers and stuff like that without having to worry about all these other components. So let's try this out. We're using Django. So Django's awesome, like we said. So let's go try and implement this style of coding and architecture in Django. Django, it just sits there. That's a little funny thing that we had at DjangoCon last year. Essentially just a module, right? Like it shouldn't make that many influences over the code that you write with Django, but it turns out that's not actually the case. So we're going to replicate that architecture that we were talking about earlier. We have like a front-end API and an API service, and with our hipstagram clone, right? So essentially, when you try to implement this thing in Django, like let's say you're building the API side where you're serving the API for the users. You're going to kind of run into these things that you'll notice it's a little bit of an impedance mismatch with the Django way of thinking. You try to like build, let's say, a lot of these little services, you'll notice that there's a lot of like significant boilerplate that's required just to generate like very small little applications and views. if you're not really using the database anymore, you don't necessarily need templates and tags and things like that, which is one of the, one of these really great things that Django gives to you. If you're trying to serve up a lot of APIs, a lot of the libraries are pretty buggy. There's a lot of work that's being done to improve this, but they could use some love. And then you have like these weird request method dispatch things you have to do. So you have to and apparently class-based views make this better, but they're undocumented, so we're gonna pretend that they don't exist. But you're gonna have to have these big if chains where if it's a post and do this, and if it's a put and then do this, and it's just not a very natural way to think about these things. So when we're building a service like this, we you're not gonna be using the database anymore, essentially. Because let's say we're going to have an API that's actually communicating with the database. So you'll notice in Django, when you're not using the ORM anymore, there's really not much left to use. And that's the main thing that Django is essentially a lot of code around an ORM. So you'll notice that everything is essentially tied to the ORM. So if you have a third-party tool that you're trying to use, one of those Django apps that are canned that work really well, they all use the ORM. So if you're not using the ORM, it's just completely useless to you. And even the user model requires sessions and doesn't let you rip them out, and it's not very flexible. So you'll notice what's left when you take all these things out of Django. We take the ORM out, essentially you have two things left, and it is a crappy templating system and a crappy regular expression routes, which are not a very pleasant experience. So if you want to build tools or build services like this, I highly encourage you to look at Flask. And Flask is essentially a really great routing system with really great templating engine, and that's pretty much it. It's very simple. So it's essentially an HTTP web framework. It's built on top of a library called WorkZug, and it's really, really great for building web services. It's really elegant and simple. So building those little example apps that were really difficult to do before in Django, this is a full Flask app, and this is the whole thing. So you just import Flask, you have a route for a function which returns a string, which is your view, and then you just tell it to run a development server, and it just does that. It's 5 lines of code. It's really nice and simple, and that's all it is. There's nothing complicated about it. No magic, none of this settings.py and all this weird stuff. It has a built-in templating system, which many people consider one of the best templating systems available for Python. It's extremely fast and significantly, its optimization is tremendous compared to Django's. You'll be surprised at how much a Django application spends on rendering templates if you're not careful, if you're not doing caching properly and stuff like that. So it has an active community. There's extensions for everything. It's pretty awesome. So it actually started out as an April Fool's joke a couple years ago. Essentially, there was this, it was called Denied, and if you actually Google Sinatra for Python, it's still the thing that comes up on Google. And essentially, it was the whole thing was great. If you go look it up, I highly encourage you to, because it's this big troll. It has a lot of very subtle things that annoy really advanced, these normal Python developers, from denied imports star and things like that. And if you actually go and look at the code base, it's actually just a base64 encoded zip module at the bottom of a string, and it's all it does is it's all of WorkZug and a couple lines of code. Base64 is zipped encoded. The whole thing is one line. So no one even bothered to look at the code. And this thing got 800 GitHub followers one day. It was on April Fool's, and no one really it never registered with anybody that it was a joke. It was pretty awesome. So Armin took that, and he decided oh, this has got so popular, I should really build this thing properly because there's obviously a need for it. So he did. That's what Flask is now. And it's pretty small. It's only 800 lines of code itself. Everything else is kind of the WorkZug layer that's lower beneath. But out of those 800 lines of code, there's also 1,500 lines of tests. So there's a lot of really great tests and a whole lot of documentation. There's 200 full printed pages of documentation, which is fantastic because just like Django, that's a really top, one of the best features of Flask is the documentation. So it has a layered API. It's built on WorkZug and WSGI. So if you ever want to return a WSGI view or return a WorkZug view, you can at any point. It lets you go and dip down into the layers. Every view is actually a separate WSGI application, so you can kind of do some cool plumbing work there if you want. Some big differences with Django and Flask are that they're explicit and passable app objects. So in Django, you have this weird global state with these environment variables for defining where your connections are, or your settings file, I should say. And in Flask, essentially, you have like an actual app object that you actually import, and you can pass them around. You can have like 20 of them in a process if you want. It makes it really easy to test. Really simple APIs, no boilerplate. BYOB, which is bring your own batteries. Essentially, like one of the big problems with Django is when everything relies on the built-in batteries in Django. If you want to change the default behavior, it's really hard to. So most people just end up like forking Django or something like that, and it's really not a good experience. So like, you know, Flask essentially just gets rid of that by not having any batteries at all, and it makes it a pretty nice experience. So there's no built-in ORM either, form validation like there is in Django. Most people use something like SQL Alchemy or WTF forms, but like those are all choices you can make, and if you don't want to use those, you know, those things that the community usually uses, you're not forced to. You can just use anything else, and it's pretty nice. And another big difference is that there are context locals, which keep things looking like nice and clean, and they're a little confusing at first. Like in Django, when you have a view, essentially you have the first parameter to the view function is a request that gets passed in explicitly, and in Flask, essentially you have to like import request at the module level, and it's automatically populated, which is a little weird, but essentially it helps with the plugin system to make things a little bit simpler. So there are actual reasons for that. It's not just an arbitrary decision. Some improvements over Django, that the fewer batteries equals greater flexibility. Django 2 is fantastic. Everything harnesses actual references. There's not like this weird settings.py string automatic import path hacking thing like there is in Django, which no one understands. And the best part is like configuration is just an actual dictionary. So like it's like, there's nothing special about it at all. It's not like a proxy or this weird like lazily evaluated settings.py file. Like it's just a dictionary. You can do whatever you want with it. It's really simple. And so one of the biggest problems with Flask for a long time that people were kind of raising when it came out was that it was really hard to build large applications with. So you'd go and you'd like try to start building up like these sub-modules and things and like doing these pluggable architectures like you have in Django, and Django makes those decisions for you and Flask doesn't. So that's a big deterrent for building large applications. And essentially, for a long time, my answer to that was like, well, you know, I actually like coming up with those import systems and things like that. I think it's nice. But it turns out that's actually the best part about Flask is that it actually makes it really, really hard to build these applications, and it's something that you probably shouldn't be doing at all in the first place. So like, it's a very nice constraint that fosters great code. So it'll actually encourage you to either put the work necessary into actually building that large application if you need to, or reconsider your options and make it a more service-oriented architecture, which I think is usually a pretty good approach. So yeah, some other improvements are there's a workzug debugger built into it, which is considered by many people to be one of the best HTTP debuggers in the world. So essentially, like you can use it in Django as well. There's like a little plugin. But like if you have a debug mode turned on and there's an exception that's raised, you get like an interactive interpreter in your web browser that you can introspect, which is really, really nice for developing applications. There's no like import time side effects, and there's like some nice little shortcuts, like you can just return a tuple with the content string and the status, and it'll just like work. You don't have to import response to do simpler responses, which is pretty cool. If you're going to be using Flask, and if you're coming from the Django world, there's some extensions that will probably be pretty useful to you. There's Flask SQL Alchemy, which is, SQL Alchemy is considered by many people to be one of the best ORMs in the world. It's extremely advanced, and if you think it won't suit your needs, you're probably wrong, according to the maintainers. So it's much, much better than the Django ORM. And if you like the expressiveness or like the way that the like less than and all these different things in the Django ORM work, like you can just essentially add them to SQL Alchemy with like 8 lines of code, which is pretty awesome. So I highly recommend you check that out if you're going to be using Flask. There's also Flask Celery, which essentially works the same way as Django Celery. Flask Script, which gives you manage.py. You can do like manage.py run server and stuff like that, which is a nice little added bonus. And I wrote a couple, but we're running out of time, so I'll skip those. So essentially, Flask is a sharp tool for building sharp services, and you should be using the best tool for the job. So if you find yourself torn between Flask and Django, between alcohol versus ponies, you can always realize that you can use both at the same time. Essentially, services are agnostic. It doesn't really matter as long as you're picking a common protocol. And in this example, we're speaking HTTP, so just speak HTTP and everything will be fine. Any questions? Awesome. Anything at all. Cool, thanks.